Cool. So yeah, hi guys. This is Chris from DoraHacks. Welcome everyone to join the second Archway Hackathon workshop, interacting with the Archway reward system. Today we are very to welcome Augusto from Archway and PhiLabs team as a guest speaker again. He is currently a developer experience engineer in the PhiLabs and Archway. A bit background intro for the Archway Hackathon. We are super excited about it because this is actually the very first one that we support, not only for Archway, but also for Cosmos ecosystem and developers as well. We are very looking forward to see different type of the projects, toolings can be emerged from the Archway hackathon and Cosmos ecosystem in general. Right now, we have already received a little bit less than 20 product submissions for the hackathon. So if you are developers and trying to build something exciting in the Cosmos ecosystems, please feel free to join the hackathons for now for free. Okay, so back to the workshop. Today we will cover the topics about how to interact with reward systems from smart contracts, how to create a DAO to manage funds, assign funds to specific users delegating at a particular block. Augusto, I think right now you can take over the stage from here. Feel free to start when you're ready.
Cool. Thank you very much, Chris. And thanks everybody for joining today again. So I'll be talking about how you can interact with the DApp reward system from your smart contract in Archway. But before that, I will give an introduction to how the different rewards work inside Archway. A little bit about me first. I'm lead software engineer at PhiLabs and a contributor to the Archway network. And if you want to find me in Twitter, here's my Twitter handle, @LSBal. So DApp rewards. If you watch the previous workshop, this is just like a quick recap, but the three different types of rewards that Archway provides are gas rebates, which are split 50% between smart contracts and validators. And the gas rebates, they are basically a rebate on the transaction fee that was spent in the smart contracts. Inflation rewards, which are accrued for every block that's minted, there's an inflation, and 25% of this inflation goes back to smart contracts, the other 75% to validators. And the third type of rewards are the contract premiums, which go 100% to the smart contracts. And all those reward models, they are baked directly into the protocol. And an important thing to notice is that all those parameters, they are adjustable via on-chain governance. So if the community wants to modify any of those at any time, they are allowed to do so with a governance proposal. So first, about gas rebates. Gas rebates, as I mentioned, it's a fair split between the validators and the smart contracts. And the gas rebates, they are calculated based on the consumption of the smart contract for a given transaction. So let me go to an example. Imagine that we have this transaction, and the beginning of the transaction, we have all the Cosmos SDK operations happening, and then at some point, the Cosmos SDK will begin the WebAssembly call. And at this point, your smart contract is executed inside that transaction block. So this orange block is for the portion of the contract that is executed. And then after that, it goes back to the Cosmos SDK to finish the boson call and run other tasks before finishing the transaction. But inside your smart contract, imagine that you're doing the following. You're calling another smart contract, and these smart contracts corresponds to 50% of the transaction, okay, that your smart contract actually run in total. So, okay, now we have the situation where inside your smart contract, you call another one, which consumed 50% of the fees. What happens next? So imagine that the entire transaction consumed 300 micro arch. If you're not familiar in the Cosmos ecosystem, it's common to use these micro as the minimum. You can imagine as satoshis in the Cosmos ecosystem. So 300 micro arch that the user paid in total for that transaction to be executed. This is the gas costs. But for the contract execution, 200 arch were spent only for that portion. So the other 100 are related to tasks running inside the Cosmos, the protocol itself. So how do we calculate the rewards in this case? So as I mentioned, 50% of the rewards are split between contracts and validators. So it means that the rewards, they correspond to 100 micro arch. Okay, so it's the 200 of the contract execution. So though only this portion of the fees are rewarded, and from those 50% are the rewards that will go to the contract. But here in this situation, we have the contract calling another one. So what happens? As it's mentioned here, proxy contracts, they are not incentivized in Archway. So each contract that is called inside the transaction block will receive their fair portion of the rewards. So since the contract in black corresponded for 50% of the execution, so the rewards are split between those two contracts. So that's about gas rebates. The next one are the inflationary rewards. Inflationary rewards, they are, well, first about the inflation in Archway. The inflation in Archway follows the same model as in the Cosmos Hub, between 7 and 20% annually. And as I mentioned, 25% of this inflation will go to the dApps. And this parameter can be adjusted via governance, but how does it work? Imagine that in a block, a contract was responsible for 50% of the gas that that entire block consumed. So from those 50%, 25% of the inflation will go to the 50% of the 25% of the inflation will go to the smart contract. Okay, so it's based on how much of the block a smart contract consumed with transactions. And the contract premiums are pretty simple. They are just a flat fee that you can charge in addition to the gas consumed by the transaction. So as the name says, it's a flat fee. You just specify, hey, I want that for every single transaction in this smart contract, the user pays a flat fee of 0.1 arch. This can be used to cover I don't know, costs related to, imagine that you are doing NFT marketplace, that you're shipping physical goods to the user. So you want to pay for the shipping costs. You can put those costs inside those flat fees, and they can be adjusted at any time you want. So it's just like a very simple example, but you can use for many use cases. And here, the user will pay only for what they used. So if the transaction fails, this fee asked by the contract premium will be refunded in total to the user. And they are the premiums, they are obtained by default. So by default, the contract doesn't have any premiums specified. You need to manually inform these after you deploy your smart contracts. Okay, and one important thing here, like how do we enable the contract rewards? Okay, so the first step, as conventional for any Cosmos chain. You store, instantiate the contracts, and after you do those steps, then you have to set the contract metadata. In the contract metadata is the information you need to specify are the owner of the metadata, so an account that will act as an admin for that contract metadata. So this can be a user account or a smart contract, doesn't matter. But after you specify the owner of the metadata, only that owner will be able to modify the metadata again. So this is an interesting use case because, for example, imagine that you want that the rewards destination is controlled by a DAO, a smart contract. So when you are specifying the contract metadata, you can specify the owner of this metadata should be the DAO smart contract. And then in this case, only this smart contract will be able to modify the rewards address at any time. And this can happen via governance in the protocol, whatever you code the way you want. But this is an important feature to increase security that you won't have a rug pull. You can basically verify, don't trust, verify, right? So, and in the contract metadata, as I mentioned, you can also specify the rewards destination. After that, you can optionally set the contract premiums. They are not mandatory. It's an opt-in feature. If you want, you can, at this point, specify the flat fees for your contracts. And, well, then you earn and withdraw rewards. It's for every successful transaction in the contract, you will receive the gas rebates, inflation, contract premiums if they are activated. And then those rewards, they will be accrued to an address. And it's important to mention here that those rewards, they are not sent straight to the address. They are saved inside the chain. Okay, so it's a lazy model for claiming the rewards. So the user, the smart contract, whoever is the receiver of the rewards, they have to manually claim the rewards. And this is an important distinction because this enables more use cases for the rewards. When you are withdrawing the rewards, we will go into the details of the information contained in the rewards. The reason for you to withdraw them manually is that you can, at this point, verify when, at which point in time a reward was generated. So, for example, imagine that the rewards are sent to a smart contract address, and then you want to reward everybody who's participating in a liquidity pool, and you want to reward them based on their on the time of their contribution. So by getting the information of when the reward was generated, you can assign the rewards for the users that contributed on a specific block or that are contributing since block X, Y, whatever. I will go into the details so you will have a better understanding of that. And how do we use the rewards inside the smart contracts? If you're familiar with Cosmos, this is not new to you, but if you're new to the Cosmos ecosystem, this happens via something called the WASM bindings. And the WASM bindings, they work as an entry point for smart contracts to interact with the protocol. There is these Rust crates available, Archway bindings. I will show a bit of the source code quickly, but basically those bindings, they contain messages and queries that you can use to transact or to query the state of the rewards in Archway's protocol. So here on the right, we have an example of the Archway message struct with the messages it supports, so we can update the contract metadata, and all that can happen from inside the smart contract. Okay, so we can update the contract metadata, specifying an owner, a rewards address. We can set a flat fee. We can withdraw rewards, and we can even withdraw rewards by specific record IDs. We will check that in a second. And for the queries, we query the current metadata for the contract, the flat fees, the available rewards. And this is another query for governance votes. It's to enable another feature in Archway. We won't go into the details of that in this workshop, but it's basically to query for available governance votes in a specific proposal. Okay, so now let's go to the codes. Let me open here. First, I will show the Archway bindings. I hope this is big enough for everyone to read. So the Archway bindings, as I mentioned here, these crates can be imported into your smart contract, and the messages defined here. We have like some helper methods to facilitate the creation of the structs, and it's pretty simple actually. It's not it's just like plain structs with the messages we will use to interact with the protocol. Okay, and here inside the contracts folder, we have working implementation of how you can use those bindings inside a smart contract. So here we have the default increment smart contract with some custom messages to interact with the rewards module in many ways. So I will show to you in another example here. And this example, this is a follow-up from our workshop, okay? This is a follow-up from our workshop last week. This is the demo project we created, and I will go through the changes necessary here to work with those Archway bindings. So when we created the project, the Archway bindings crate was added here automatically for us, but to improve the user here, we will I added these CW utils, and this third JSON WASM. I will explain both why we need both crates soon. So besides having the Archway bindings crates, another thing we need to change is the result type of the entry point methods. So the default here is this results type with response, and we change everything to Archway results, okay? And here in the execute method, I added one new method, which is withdraw rewards, okay? And the withdraw rewards, what it does, it simply creates this Archway message with withdraw rewards by limit, and I specify 0 here because this way it will withdraw all rewards available until the maximum limits that the protocol supports for every withdrawal, which I think it's 2,500 rewards. Again, this is also another parameter that can be modified by governance. And then when we are replying, we are creating the response object. We just add this message. And with that, the Cosmos VM will understand that, okay, now we need to execute this message call inside the protocol. And then, as I'm specifying here, I'm adding a message with a reply. Okay, so I will send this message, and I will wait for a reply. So this is not like a method that you call inside the library. Okay, this is a part of the how the Cosmos actor model is structured. I mentioned a bit about the actor model in the last workshop as well. So basically you send the message and then you have to specify an entry point to receive the reply from the protocol. Okay, so this happens as well when you're calling other smart contracts, etc. You send a message and you wait for the reply. And here we added this new entry point for to get the reply. And this constant that is specified here is just an ID, so we can identify when we receive the message what is the ID of that message, just to forward the reply and handle the reply properly, okay? Because the reply message is a bit generic, and this, as you can see here, is just a constant, okay? So back to the code. When we are dealing with the reply, what we do, we get the binary data from the reply message, and then we use that library, the JSON WASM, to deserialize the message into the type we are expecting. So in this case, this message we sent will generate this reply, which, as you can see here, is inside the Archway bindings crate. And the withdraw rewards response will give to us the amount of records withdrawn and the rewards that were withdrawn, the total amount of rewards. And then here we just use this native balance struct from CW utils to just normalize, and in case there are different coins, etc. in this response, we just normalize just to get the total rewards properly calculated. And then we just add this to the response attributes. So that's those are the basics for withdrawing rewards inside the smart contracts. Unfortunately, due to the lack of time, I won't be able to show like a full example on how you can do that with inside the DAO, and how you can automatically distribute that fairly to the users based on the time they are participating in that DAO and so on. But here is the main points for you to look at when you are interacting with this module. And the other important part is the query. Okay, so here we have an outstanding rewards query, and the outstanding rewards will simply return a list. And here, in this case, the query, it's just a method call. So there's no complication between sending a message, waiting for a reply. It's just a simple function call. And here we call, inside the Archway query, we call the rewards records with pagination. We specify what's the address we are querying. And in the response, it will return this rewards records response. And in the rewards records, as I mentioned before, we have, for every single reward generated, we have the amount of rewards, the coins, the calculated height, and the time that this reward was generated. So here, by issuing this query, you can work with the results of this query to properly assign, and okay, so just as an example, you can query those rewards records before withdrawing the rewards. And this way you query the rewards, and then you store, okay, those are the rewards calculated at this specific height. Let me get the list of users that were part of the DAO at this, that, and that other height, and then do this, calculate the distribution. Then you withdraw the rewards, and you proceed with distributing the tokens to the users. So this is just the example here, but let's go to deploying this contract. I already built this contract before the presentation because this usually takes a bit of time. So I run this Archway build optimize command. But let's go then to the, sorry, let me just see if this is correct. Okay, yeah. So let's store the contract on chain. Now we instantiate. Okay. And well, we can try querying the outstanding rewards. Well, as imagine, it's empty. So let's TX with let's do a transaction in the contract. Well, as I mentioned during the presentation, we need to set the metadata for the rewards address. If we don't specify this metadata, the protocol will not be able to understand where to send the reward. So the rewards functionality will be disabled for the contract. So let's go ahead and set the metadata. But for the metadata, let me do the following. I will get inside the config file, I will get the address of the contracts. Oh, it's not allowing me to. Let me open here. So I will get the address of the contract, okay? And this information is saved inside the config.json file. And I will specify what here I'm specifying the owner address. So the owner will be Alice, the same account I'm using to deploy and manage the contract. The rewards address will be the contract itself. Okay, so the metadata as specified, Alice as the owner, the contract as the rewards address. And now if we transact with the contracts, let's transact again. Just generate more rewards. Let's query the outstanding rewards. Yeah, so here we have the rewards, and this is just a sum of the rewards. So here I'm using again this native balance just to sum the total records. But let me show here inside Archway. Okay, so this is another binary. This should not be confused with the Archway CLI. This is the Archway binary from the Archway protocol itself. So let me query the rewards for these contracts here. So let me open again the config file, the rewards. Sorry. Yeah, contract. That's correct. Okay, so here we have the full breakdown of that query of the rewards record. So here we have the rewards, breakdown of the rewards, the calculated height, the time. So we see that I run 2 transactions, and because of those 2 transactions, we have 2 rewards. Okay, so now let's run withdraw rewards from inside the contract. Okay, because since the rewards address is the contract, only the contract can claim the rewards. So now we claim the rewards inside the contract. Let's query it again. Okay, important. We have 1 reward here. Why? As you can see here, the ID of those rewards are 771, 772. But here we have a new reward, 773. So it means that the other 2 rewards were withdrawn. But since we had to execute a transaction inside the smart contract to withdraw the rewards, these generated rewards again. So yeah, here I'm done with the demo. I think we have 1 minute. Sorry to be short on time. I don't know if we have time for questions, but yeah, that's it.
Sounds great. Yeah, thank you very much, Augusto, for another detailed workshop for our developer communities. Definitely very insightful and very useful for like even non-developer like me to better understand about how reward systems works for Archway. I think, oh, there's one question. Where are these rewards from the withdrawal transaction going to, want to, yeah. So where are these rewards from the withdrawal transaction going to? Oh, you are muted.
I'm sorry. Yeah, so in this case, since the contract is withdrawing, we can query, Archway query banks, and then if we query the balance of the, I'm sorry, I'm getting confused. Yeah, so in this case, these rewards, they went into the contract, okay? So we can get it here, rewards record. So yeah, so as you can see, the balance, this is the bank balance of the smart contract itself.
Yeah. Yeah, I think actually that's all of the questions that we have for today. It's a little bit over time, but yeah, appreciate your time for the workshop. So guys, if you have more questions, since the limited time, we cannot ask here, but you are very welcome to join the Archway Discord channels. They will have office hour every week for the hackathon and developer teams, so that you can ask whatever you have there. And also, we will host a bunch of the Archway hackathon related events in the future, including workshop, project demo sessions. So if you are interested in those, please feel free to subscribe our social channels, and we will keep you guys posted there. Thanks everyone for joining us today again. Hope to see you guys soon. Thank you, Augusto, for the workshop.
Thank you again, Chris. Bye-bye.
Bye.